Bearcats. This is Unit 3, Precal Advanced, and this is Part 1 of our pre-test, which is like our review. So let's take a look. These are multiple choice, but we're going to work them out. They will not be multiple choice on your test, so this just gives you an idea. So we're going to try f plus g of x, and we're going to find f plus g of 3. Well, first of all, when you see f plus g of x, I want you to think of f of x plus g of x. Or in the second case, f of 3 plus g of 3. And that will help a lot. All right, let's just do the first one. F of x is 3x squared minus 4x plus 5. And we're going to add to that g of x, which is 2 plus 2x plus x squared. And then it's really about just combining like terms. So we have 3x squared and x squared. We have 4x squared. Well, that immediately you can see that you've eliminated those two if we were multiple choice. Then we have a negative 4x and a positive 2x, so we have a negative 2x, and we have a 5 and a 2, which is positive 7. All right, so now we have that, so now let's decide about the 3. So we're going to take 3 and we're going to plug it into this, and we're going to take 3 and plug it into this, and then we're going to add them. I think since we have already added these two together, you could have added the equations together and then just plugged in the 3 for these x's. Let's just try it out to make sure. So the first one, we would have 3 times 3 squared minus 4 times 3 plus 5. And we'd be adding to that 2 plus 2 times 3 plus 3 squared. All right, so 3 squared is 9. 9 times 3 would be 27. 4 times 3 would be negative 12 plus 5. And since we're adding, we would say plus 2. Plus 2 times 3 is 6. Plus 3 squared is 9. And we would add up all of our answers. Now, a little easy way to do this. We have a positive 27, a negative 12, and the rest are positive. So we have a 27, and we have a 9. That would be a 36. So we'll get those done. And then we have 6 more. That would be 42. And that's 44. And that would be a 49 minus 12, I believe. And that would give us 7, and that would give us 37, and that would be our answer right here. So this would be our final answer. Now let's try what we said a while ago. Since you already added the functions together and then are going to substitute in, I think it makes our math a little simpler. So let's try that. We would have 4 times 3 squared minus 2 times 3 plus 7. Let's see if that works. 3 squared is 9. 4 times 9 is 36. Negative 2 times 3 is negative 6. Okay, so that would be 30. And then plus 7 gives us 37 also. And I think that math is a little simpler. You could do it either way, but I think that would work. All right, let's go into the next problem. Now we're going to find f times g of x. So again, we're going to go f of x times g of x. So we're going to have f of x, which is 25 minus x squared, and we're going to multiply times 5 minus x. And then it's just old-fashioned FOILing. 25 times 5 is 125. 25 times negative x is negative 25x. Negative x squared times 5 is a negative 5x squared, and negative x times negative x squared times negative x would be a positive x cubed. All right, and it looks like they've put them in the right order. Well, here's your positive x cubed. Here's your negative 5x squared. Here's your negative 25x, and here's your positive 25. Looks like that's our answer. All right, moving right along. Now we're going to divide. We worked this one in class, but let's take a look at it. We have f of g over f divided by g of x. So we have f of x divided by g of x. So f of x is 1 over x, and we're going to divide by x cubed. All right, be really, really careful. This big fraction bar right here, Ms. Zorn likes to think of as old-fashioned division. So we really have 1 over x divided by x cubed. And I'm going to put that over 1. Well, you remember from middle school that instead of dividing, when you're talking about fractions, you could multiply by the reciprocal. So we would have 1 over x times 1 over x cubed. you'd multiply straight across. 1 times 1 is 1, x times x cubed. Add the exponents, keep the base, x to the 4th, and that would be your final answer, which would be this one right here. All right, moving along. You can stop and pause if you need to. All right, now we have f plus g of x, f plus g of 3 for these. A very similar process that we had a while ago. Let's go ahead and do the 3. Since all of the answers are different, that should give us our answer, and I'll let you go back and do that. And we'll do both in combination with that. So we're going to add them together and then substitute the 3 in. So we have f of x, which is 2x squared minus 3x plus 4. And we want to add to that negative 1 minus 2x plus 3x squared. All right. So we have a 2x squared and a 3x squared. So we have 5x squared. We have a negative 3x and a negative 2x. We have a negative 5x. And we have a 4 and a negative 1. We have a positive 3. So now we're going to plug in our 3, since we've simplified it. And we will get 5 times 3 squared minus 5 times 3 plus 3. 3 squared is 9, so 5 times 9 is 45. 5 times 3 is negative 15 plus 3. All right, well, we have a 45 and a 3. That's a 48, and we have minus 15. So there's your 3, and that would be your 3, so 33. And I believe that brings us to this answer right here. Plus, it matches when we combine them. All right, go Bearcats. All right, now we're going to get to compositions. Compositions are really, really, really important to future mathematics and your future math classes. Are the whole concept of taking one thing and using it to find a solution and then using it in something else is really, really important, both in math and in your physics classes. So please pay really careful attention. We're going to first do fog, and then we'll do golf. So fog, really, when you see that, you're going to write as f of g of x. So we're going to take the g of x stuff and plug it in f. So the g of x is x squared plus 2, and we're going to plug it in for the x in the f function. So we're going to have 5 minus 2, and instead of the x, we're going to put all the g information in there. X squared plus 2. If that's confusing, sometimes when I first learned this, I did this. I did f of. Okay, g of x is x squared plus 2. And that made more sense to me. So then I looked at my f function. I thought I have not f of 3, but I have f of x plus 2. So x plus 2 has to go in for the x. Maybe that'll help you. All right, so we have 5, and then I'm going to have a negative 2, and I'm going to distribute. So negative 2x squared. Negative 2 times positive 2 is a negative 4. 5 and a negative 4 is 1. So I have negative 2x squared, and I have plus 1. And that is when I fog. So let's see if we can find that one. Negative 2x squared plus 1. It looks like this is going to be our answer. I'm going to go ahead and golf for you real quick, but just so it's not multiple choice, so you need to know how to do both. But there's your answer. All right, so you can check to see if you get this one. So if we golf, we're going to go g of f of x. And using this same little principle up here, let's do that. Let's do this. Let's say g of. Okay, well, f of x we know is 5 minus 2x. So we're going to plug 5 minus 2x in for all the x's in the g function, which would be that x. So parentheses 5 minus 2x, and we're going to square it, plus 2. Okay, this is where we're going to use our binomial shortcut again. You guys need to really learn that. It'll help save you some time. If you don't, you're going to go to the side of your paper and you're going to multiply out 5 minus 2x times 5 minus 2x. You'll FOIL and combine like terms. But I'm going to use the shortcut. Take the first term and square it. 5 squared would be 25. Multiply the two terms and the 2, the square, that number 2, multiply each term times 2. So 5 times negative 2x would be negative 10x. Negative 10x times 2 would be negative 20x. And then take the last term, which is negative 2x, and square it. That'd be negative 2x times negative 2x would be positive 4x squared, and then still plus 2. So we're going to combine that with the 25, and that's going to become a 27. And we have negative 20x plus 4x squared. So positive 4x squared, negative 20x, a positive 27. That matches up to what we thought. All right, go Bearcats. All right, in this next problem, we're going to just golf. So we're going to go g of f of x. All right, f of x. What is f of x? F of x is going to replace 3 square roots of x. So we're going to take 3 square roots of x and plug it into the g function for our x. So we have 3 square roots of x minus 7, and that's really all we can do here. So 3 square roots of x minus 7, there's your answer. Do not do more than that. All right, let's move on. Next, we're going to fog. So we're going to f of g of 5. All right, well, first of all, I'm going to figure out what g of 5 is. I'm going to do that to the side. So I'm going to pretend like this is not g of x, but g of 5. That means I put a 5 in for x. So I'd have g equals, or g of 5 equals 5 plus 8, which is 13. So g of 5 is really 13. So now I have f of replacing 13. Now I'm going to put 13 into my f function. So I would have 2 times 13 plus 6, 26, plus 6 is 32. Bam. There's my answer. Go Bearcats. All right, now we're moving into the inverse functions. We have a function -2 with ordered pairs -2, -7, -7, -2, and 6, -4. If we want the inverse of that, you should know you're going to take your x and your y values and you're swapping them out. So instead of -2, -7, you should see a -7, -2, -7, -2, -7, -2, -7, -2. I don't see that one here, so we can cross that one out. Then you should see a -2, -7. Don't see that here. -2, -7. Don't see that here. This is probably my answer, but let's double check. We should also see a -4, 6, -4, 6. Bam. There's my inverse function. Just took each ordered pair and reversed their x and y's. All right, let's moving on. All right, are the following functions inverse? If not, rewrite the second so that it's an inverse of the first. Well, let's just figure out if they're inverses or not. If they're inverses, this is like you're checking. Are they inverses? That's asking you to check or to prove or to verify that they are inverses. You will have to do this on your test. That is when we fog and we golf. And each time they have to end up equaling x. So let's see if that happens. So let's fog f of g of x. So g of x, remember, is, we're going to say f of 3x minus 1/3 because that's what g of x is. So we're going to plug in all of this for this x. So we have 3 times parentheses, 3x minus 1/3, and then plus 1. Well, 3 times 3 would be 9x, and 3 times -1/3 would be minus 1, and plus 1, that goes out, but that's a 9x, not just an x. All right, so let's try again. So let's try g of f just to prove that we're not wrong. So we have g of, and then f of x was 3x plus 1. So we just take 3x plus 1 and plug it in there. So g of 3x plus 1 looks like this. 3 times parentheses 3x plus 1 minus 1/3. So 3 times 3 was 9x. That would be positive 3 minus 1/3. Well, that didn't work out either. So neither one of those came out to be x. So if not, so we're going to say it's not. So it is not. Write the second function so that it is an inverse of the first function. Write the second function as an inverse of this. So we want the inverse of the first function. So we're going to come down here. This was just proving yes or no. And we're going to write an inverse. We're going to write this originally as y equals 3x plus 1. We're going to switch the x and y's and say x equals 3y plus 1. And then we're going to solve. So we're going to subtract a 1 first and get 3y equals x minus 1. And then we're going to divide everything by 3. So y would equal 1/3 x minus 1/3. That would be the inverse. And you would write it as f or g. You can write it as a g of x. Or you could write it as f inverse x. And that would be 1/3 x minus 1/3. So 1/3 x minus 1/3 looks like this one right here. There's our answer. You might pause and think through that a little bit. You will be having to find inverses on your test. All right, we have more practice. Find the inverse of the function. So this time we're just finding it. So we're going to write that as a y value. Make that a y. And then we're going to switch our x and our y. So we're going to make this x equals 2y plus 1/3. All right, the first thing we're going to do is subtract the 1/3, and we'll get 2y equals, and we're taking 1/3 away from x, so x minus 1/3. And then we're going to divide by 2. Dividing by 2 is the same as multiplying by 1/2, and sometimes that's easier to think about. So we have to multiply all of this by 1/2. That goes, and y equals, and we're going to distribute. 1/2 times x is 1/2 x. 1/2 times 1/3. Multiply straight across, you get a -1. That would be 6. So 1/2 x minus 1/6 is our inverse function. And I think it's right down here, 1/2 x minus 1/6. And make sure you note the notation that now becomes f inverse x of x. All right, so there's our answer. Go Bearcats. All right, once again, we're going to show, prove, verify. Those are all words that mean the same, that G, F, and G are inverses. That means we have to fog and golf, and each time our answer has to come out to 0. So when we F of G of X, it should equal X. And when we G of F of X, it should equal X. So let's do that. So first let's fog. We're going to take the G function, and we're going to plug it in for the X here. So we're going to have 4x minus 8 over 4 and then plus 2. All right, well, let's rewrite this as 4x over 4 minus 8 over 4 plus 2. 4 over 4 goes out, we have an x. Negative 8 over 4 is negative 2 plus 2. The 2's go out, and we're left with just x. All right, well, that's a good sign. Now let's prove the other one. Let's prove the other one. And let's look here. We got 4x minus 8 over 4 plus 2 when we fogged. Fog, 4x minus 8 over 4 plus 2. All right, that's right. If we pulled out the 4, then it would have been minus 2. It would have been x minus 2. That would be x, and that would be, so minus. So those don't work because those say plus, so we can take those two out. All right, now let's keep going. So let's try G of F. F of x, that's going to be all of this. It's going to go in for this x. So we have 4 times all of this, x over 4 plus 2, and then minus 8. All right, and let's see. So 4 times x plus 4 over 2 minus 8. This looks like the right answer. So I think this is going to be our solution right here. But let's go ahead and just do it algebraically. So we're going to have 4 times x over 4. So we'll have 4x over 4. And we'll have plus 4 times 2 is 8 minus 8. Well, the 4 over 4's cancel. The 8 minus 8's cancel. And we're left with just x. Woohoo! There is our answer. They are proven both ways. They both equal x. So we have proven that they are inverses of each other. All right, that may take a little bit of time for you to absorb and work through on your own. Do that, and then I'll be right here waiting for you. Okay, in this next one, we're going to graph the inverse function. There's a couple of ways to do this. The first thing I would do is just going to come up with 3 ordered pairs from the original function and then just reverse them to graph my new function. You could also go ahead and algebraically solve it and graph that. So we're going to show you both ways. I actually think if you have an equation, it might be easier to come up with the ordered pairs, but that's up to you. So I'm going to come up with 3 ordered pairs. And I'm going to pick just values I want. I'm going to pick a 0, and let's say I pick a 1, and I pick a -2. I can pick anything I want. All right, if I put in a 0 for x, I'm going to end up with 0 plus 1 is 1. So 0, 1 should be on my original graph, not my inverse. This is the inverse graph we're looking at below. If I plug in a 1, I get 2, and 2 plus 1 is 3. If I plug in a -2, I get a -4, and a -4 plus 1 gives me a -3. That would be my original graph. For my inverse, I would have 1, 0 on my graph. I'd have 3, 1 on my graph, and I'd have -3, -2 on my graph. All right, let's see which one of these works. Do I have 1, 1, 0? Nope, not on this one. This one doesn't work. Do I have 1, 0? Nope, this one doesn't work. Ooh, do I have 1, 0? Yes, I do right there, but I also have it right there. All right, let's try another one. 3, 1. So 1, 2, 3, 1. Ah, it looks like that's on my graph over here. 1, 2, 3. That also maybe looks like it's on my graph. 2, 3. That may be a little above, but we'll see. All right. Now let's try -3, -2. So 1, 2, 3, 1, 2 would be right there. Oh, not on my graph. Let's see about this one. 1, 2, 3, 1, 2. That would be on my graph. I believe this is my correct choice. And that's how I would graph it. If I were given a function, I'd find those ordered pairs. I would reverse their order, and I would graph these 3 points and draw my line. All right, now if I wanted to do it algebraically, I could make this my y and switch them out. So I could say x equals 2y plus 1 and then solve for y. So I'd subtract the 1, so I'd have 2y equals x minus 1, and I'd divide everything by 2. So I would have y equals 1/2 x minus 1/2. And that's good, except that you would have to go in and graph -1/2, which it looks like right there is -1/2, and you would have to have a rise over run, so up 1 over 2, up 1 over 2, and that looks like it works in this graph. If you were doing it graphically on a graph yourself from scratch, you would have to graph it -1/2, and then you would have to count up 1 over 2, down 1 over 2, you know, to get to your other points. I really like this method up here. I think it works really good. Go Bearcats! All right, next we're just looking at the horizontal line test to determine which of the following has an inverse. All right, function, which of the following functions has an inverse function? All functions can have inverses. It's just that their inverses may not be a function. Horizontal line test. If the horizontal line test is passed, then when you do an inverse, the inverse will also have a function. So this would pass a horizontal line test. This would not pass a horizontal line test. This would not pass a horizontal line test. This would pass a horizontal line test. So it looks to me that 1 and 4 would pass the horizontal line test, and their inverses would also be functions. Their inverses would also be functions. All right, go Bearcats! All right, find the inverse of the function. If we're not graphing it, then I'm going to do it algebraically. A while ago, we were graphing. If we're graphing, I'm going to find ordered pairs and just reverse my x and y ordered pairs. I think that's just a simpler method when you're graphing. But if we are just finding the inverse, we're just going to do it algebraically. So we're going to make this the y, and then we're going to switch our x and y. So we're going to say x equals, parentheses, y minus 2 cubed plus 6. And then we're going to start solving for y. So we're going to subtract 6. And we're going to get y minus 2 cubed equals x minus 6. And then we're going to take the cube root of both sides. We're going to have y minus 2 equals the cube root of x minus 6. And then we're going to add 2. And we're going to add 2 outside of the cube root. So y equals the cube root of x minus 6. And then it's going to be plus 2 outside. And it looks like to me we got our inverse right there. All right, let's go on. I think we have 2 more problems. All right, find the inverse of this function. These are a little tricky, so I want you to pay really close attention algebraically what we're going to do. This is going to be a y. We're going to switch our y's and our x's. So we're going to say x equals 2 minus 4y over 2 plus 5y. If I have a fraction and an equal sign, I'm going to make this look like a fraction by putting it over 1. And then what am I going to do? That's right, I'm going to cross multiply to solve for y. This is a really tricky one, so you're going to have to pay really close attention. I like this problem a lot. This is more close to a pre-cal type problem. All right, when I cross multiply, I'm going to cross multiply this direction. I get 1 times 2 is 2, and 1 times -4y is -4y. Equals, cross multiply the other way, 2x, and then I get 5xy. And this is what's going to throw everybody off, and I really like this problem a lot. You need to put all the y's on the left. Remember, you're trying to get to y equals. Put anything that has a y in it on the left. Put everything else on the right. So this has a y and this has a y. So I need to move all of this to the left. This needs to go to the right. So when I do that, I'm going to get negative 4y. Well, I didn't write that right. Negative 4y minus 5xy equals 2x minus 2. Okay, I'm going to stop for a minute to make sure you understood. All the stuff with y's went left. Anything that didn't have a y in it is on the right. So make sure you're good there. The next thing I'm going to do is I'm going to factor out my y. Really, really important concept, not only now, but later on in our trig units as well. So I'm going to take a y out. And when I take a y out, I get negative 4 minus 5x equals 2x minus 2. And then I simply can divide by negative 4 minus 5x on both sides. And I get y equals 2x minus 2 over negative 4 minus 5x. Now, I look over here and I don't see that answer. But I'm looking at all the signs. There's all these negative signs. We could have factored out a negative y as well, and then that would have also helped us. What I'm looking for are the numbers first. A 2 and a negative 2 at the top. I got 2 and 2 at the top and a 5 and a 4 here. This is the closest I have to my answer. Why is it not exactly written the same way? Well, let's take a look. Let's factor this negative outside. All right, and let's factor a negative out of the top. So if we go y equals, at the top I take out a negative 1, and I get, then I would have a negative 2x plus 2. At the bottom, if I take out a negative 1, I'd have a positive 5x and a positive 4. I'm just putting them in the right order. These negative 1s would cancel, leaving you negative 2x plus 2 over 5x plus 4. Really good pre-cal problem. Please pay attention. Please make sure you can factor out that y at the right stage of the game. Like that problem a lot. Go Bearcats. Okay, this is a problem that you would do in your graphing calculator. You might want to go in on Monday morning and just practice it once. Most of you are more familiar with this than me because I don't use a calculator very often. The first thing you're going to do is open up a new document. And once you open up a new document, you're going to say no, you don't want to save anything. And then you're going to want to do number 4, list in spreadsheets. So you're going to go number 4, list and spreadsheets. And then you're going to go up and you're going to label your list X and Y. And this will be your years and this will be your distance in this problem. And you're going to go in and enter your data. Now, be careful. X is 0 for 1989. This is really a little tricky. Use 0 for 1989. So if this is 0, this is 1, 2, 3, 4, 5, 6, 7. Be really careful about that. That's really, really strange. Normally, we would have said that, 1990 was 0 and that this, we would have redone it. Or we would have said 1989 represents year 9. So read what the problem gives you. This is really good about interpreting the information given to you. So for the X list, you would put in, since it's in sequence, going by ones, you could just put in 0, 1, 2, 3, etc. And then, of course, you'd put your data 42.25, 41.75, etc. Okay, once you get your list in there, then you're going to go to, data and statistics, and you're going to go to the bottom of the screen. So you're going to number 5, data and statistics. You're going to go to the bottom of your screen, click your X, and all your little dots will go to the bottom. And then you're going to click your Y side, and all your little dots will go to the left. That's going to give you your scatter plot. If you're having trouble, come in. It'll take about 2 or 3 minutes. What you want to do before you start asking your teacher, though, is go ahead and do your list in spreadsheets and get your information in there. And then they'll help you with the rest if you need help. Once you get that, then I believe you can menu and analyze your graph. And you'll analyze regression. So you'll analyze your graph, analyze regression, and I believe it's the first one, which is mx plus b. And you should get your answer. Okay, so just to recap, you're going to open up a document, say no to save any past documents. You're going to do 4 lists and spreadsheets. You will enter your data, being very carefully to note what your x values start at. After you enter your data, then you're actually going to control doc to add a page. Okay, control doc to add a page. It'll say plus page above the document, and you have to control to hit that. Once you open a new page, then you're going to go to 5, scatter plot. Or not scatter plot, it's actually 5 is sorry. 5 is data and statistics. Data and statistics. You'll see your scatter plot. That's when you'll go to the bottom and click X to have all your little dots fall to the bottom, and then you'll click Y on the left side, and all the dots will form a scatter plot. Once you get your scatter plot, then you're going to hit Menu, 4 for analyze data, 6 for regression, and 1 for linear. And when you do, you should get this answer. So hopefully you can do that. If you're having struggling with that, then I would just say stop by your teacher. But before you ask her, go ahead and enter your data in list and spreadsheet, so it'll go pretty quick on how to get there. All right, I'm going to be back in a few minutes with part 2. Go Bearcats! All right, now we're going to go on to part 2. We're going to analyze some functions based on graphs. And I'm not going to do every one of these. We did a lot of these in class. I'll do the evens. These come straight out of your book. You can go find them in your textbook in these sections and go ahead and look up the answers if you want. But this will help you a little bit. All right, let's go ahead and look at 44. Oops, sorry. 44. Now, let's look at part 40. Wow. Not wanting to. All right, here we go. 44. All right, so f minus g of 1. So remember, we're going to write that as f of 1 minus g of 1. So f of 1. So we're going to go to our f function where x is 1. What do we get for our output? Y is 2. So f of 1 is 2. G of 1, we're going to go to where x is 1 on the g function. We're going to go up, and our output is 3. So 3 is our answer. 2 minus 3 is negative 1. Negative 1 is your answer. Negative 1 is your answer. All right, see how you do on that. All right, the next one I think I'm going to do is I'm going to do 46 g of f. And that should give you enough, and you can practice, and like I said, you can go to your textbook. So if we have g of f of 3, basically, then we're going to figure out what f of 3 is first, and we'll have g of that information. We're going to figure out what f of 3 is. So we're going to go to our f function where x is 3, go up, and our y value is also 2. So f of 3 is actually, f of 3 is actually 2. Now we have g of 2. Go to our g function where x is 2, our output is 2. 2 is our final answer. All right, go Bearcats. Hopefully you get that. Let's move on. All right, we've got a couple problems here. We've got problem B, which is on page 111. It's problem 29. I want you to work that as your example, and you can get that answer in the back of your book to make sure. Just so you know, the final answer would be I equals 0.035p. Okay, so make sure when you work that one, that's the answer you get, and you can base it off this next one that we're going to work together. This is actually problem 30 on that same page. Let's read and see what it talks about. This is about interest, and interest is basically money that you get from when you make an investment. then the bank or some company or somebody pays you interest on letting them use that money. So if you put the money in the bank is using the money. If you give money to a friend, then they're using it, and interest would be money that they're paying you for letting you borrow that money. So a simple thought would be that if I gave somebody $10 and I wanted to charge them 10% interest, which would be really high, that'd be $1 though, for if I let them use that $10 for a year. Okay, so a year from now they would pay me back with interest, so they would give me my $10 plus $1, they'd give me $11 back. And the $1 would be that interest. So that's just something really simple to kind of think about. All right, so interest on an investment is directly proportional. All right, directly proportional. Remember, that is always going to be our y equals kx equation. That's directly proportional to the amount of the investment. So by investing $5,000, okay, that's how much money we're going to invest. Remember, this would be our interest, and this would be the amount invested. I'm going to make it A for amount invested. So by investing $5,000 in a bond, you obtain an interest of $187.50 after 1 year. So our interest, $187.50, would equal our constant times the $5,000 invested. And what we wanted to do is find a mathematical model that represents this so that we could use it for any amount invested and find out how much interest we would earn. So we would simply divide by the 187, oh wrong, it's Zorn, by the $5,000 on both sides. And when we did, that would give us our constant. All right, so we need to find our constant first, and so when we divide that, we're going to get approximately 0.0375. So this constant is going to be 0.0375. Our mathematical model would look like this. Our interest is equal to 0.0375 times our amount, or our principal, since that's what they're calling it here. Let's make it a P. Our principal, which is our beginning amount that we invested. And that would be our mathematical model. So see if you can do the one before on your own like that. We're using our direct, being directly proportional, and we're solving for constant k, and then we're using constant k back in our problem and leaving the rest as variables. All right, let's move on. All right, this next problem was a lot like the one we did before with your calculator, so I would want you to work that. You can put in your information. In this particular problem, I believe they tell you that t, which represents the year, so we're going to say this equals t, and it says that t is 5 in 1995. So they would say this is year 5. And then this would be 6, 7, 8, 9, 10, 11, 12, 13. And those would be the x values in your data. And then, of course, these would be your y values in your data. And you would find your model. When you find your model, your regression line, it should be equal to something like this. Double check it. This would be another check for yourself to make sure you're doing it correctly. And then they say you want to use the model to estimate the factory sales in 2008. Well, let's go back up here. So this is 2003. So 4, 5, 6, 7, 8. Well, that would be year 14, 15, 16, 17, 18. So year 18. So 2008 is equivalent to year 18. Our x being equal to 18, our t, I should say in this case, our time is 18. So you'd want to plug 18 in for t and calculate, and you should get approximately $10,940.36. Make sure you read through that problem. Make sure you work that problem on your calculator and can get this regression formula. And then make sure you understand if you plug 18 back in that you can actually get that out of your calculator as well. All right, go Bearcats. Let's keep going. All right, these next problems are on page 113, starting with problem 55. And again, you would be able to find your answers in the back of your book for all the odds. So let's work on some of the even ones. So let's work on the second one. Y varies inversely. Okay, so we know what we're thinking is we should be thinking y equals k. It's always y equals k. Inversely would be underneath, inverted with x. So now we're going to figure out the value of k. That's what we're looking for. So we're looking for the value of k. So we have y is 3, so we would have 3 equals k. when x is, 0.25. Sorry about that. When x is 0.25. And so we'd be multiplying 3 times 0.25. And if we multiplied 3 times 0.25, that's the same as saying 3 times 1/4. Sorry, Ms. Zorn's not reading. It's 3. This is just 25, not 0.25. So this would be 3 times 25, which is 75. So K would be 75. And so your model then would just be Y equals 75 over X. And then any X you would give, you could get the Y, or any Y you were given, you could get the X. All right, let's take a look at varies jointly. Let's take a look at the one that says varies jointly, which would be number 58 in your book. All right, so Z varies jointly as X and Y. Remember, that's just things joining in on the party. Things joining in on the party. So we would say Z equals K always, and then X and Y. All right, when Z is 64, remember we're going to solve for K. X is 4 and Y is 8. Well, 4 times 8 is 32. So 64 equals 32K. We divide by 32, we would get 2. K equals 2. So your model then for this one would simply be Z equals 2XY. That's your model. All right, I think you can probably work the rest of these on your own and make sure that you are being really, really careful about the words. Let's take a look at one more before we go. We'll take a look at, I believe it's going to be 60 in your book. P varies directly. Okay, so let's take a look at this one. P varies directly, so P equals K. Directly is X. And inversely. So then immediately this division symbol or the fraction bar, inversely as the square of Y. So Y squared. Y squared. You have to write all of that out. Now we're going to plug in what we know and solve for K. That's always what we do. Plug in what you know, solve for K. And then in a minute, we're going to write our equation. We write our equation. It's going to be P equals, we'll have a value for K in a minute, over Y squared. And we're going to fill in this part right here where K goes. All right, so let's do this. So P is 28/3. I'm going to just use my space over here. So 28/3 equals K. And X is 42. And Y is 9. But it's 9 squared. 9 squared. So 9 squared would be 81. So 42 over 81. And what we could do is we could multiply by 81 over 42, and that will cross all that out, but we have to multiply by 81 over 42 on this side. Let's see if we can do a little reducing. I believe 3 goes into 81 27 times. So that would be a 1, and this would be a 27, and you would have a calculator. Half of that would be 14, and half of that would be 21, and then 7. Ooh, so 7 goes into 28 4 times, 7 goes into 42 6 times, and half of that would be 2, and half of that would be 3. So, and 3 goes into 27 9 times, and 2 times 9 is 18. I believe after all of that effort, we're going to find K is 18. So we would have 18 right here. So 18x over y squared is our answer. P equals 18x over y squared is our model. All right, go Bearcats. Take a look at those. Be careful about all these words, these squares. Inverse, you're going to put it underneath. Directly and jointly, you're going to put it next to K. And remember, the first variable introduced in the problem is always the beginning one. So it's that variable equals K and then whatever else you have to do. And that should work out pretty good for you. Go Bearcats. All right, your work problem here is problem on page 113. And it's problem 67. You really need to read through this carefully. You need to set up the problem carefully. You'll need to solve for the constant, and then you'll have to use that model to solve your problem. If you do it correctly, you should get 1470 joules. 4,470 joules. You need to work that on your own to make sure you understand it. It is in the book and it's also in your solutions manual, but you really need to work that to see if you get it. Let's take a look at these next two. These next two come out of the chapter test area, and so I believe you'll find these problems on page 122. And all the chapter test problems are in the back of the book. This one about demand. It says a company has found that the daily demand X, all right, so I'm going to write X equals, for its box of chocolates, and I'm going to write XK for constant, is inversely, okay, inversely is going to be underneath, proportional to the price. So I'm going to write my little formula. And then I'm going to solve for K, and then I'm going to write my model, and then I'm going to use it if I want to find anything else. It says, when the price is 5, the demand is 800. So X is my demand. So 800 equals K over 5. And so if I had to go through, I would multiply by 4. So I'd multiply 4 times 800. So I get 3,200 equals K. So K is 3,200. So my model would be X equals 3,200 over P. Okay, approximate the demand when the price is increased to 600. I'm sorry, increased by $6. Okay, be careful. It's increased by $6. The price was $5, so now the price is going to be $11. $11. All right, well, first of all, I made a mistake here. 800 times 5 is not 32, it's 4,000. Sorry about that. Okay, and this is a good lesson in the fact that Ms. Orange's not reading carefully. It says approximate the band when the price is increased to $6, not by $6. So we're going to have 6 there. So simply then you would have to do 4,000 divided by 6, which is approximately, oops, 666 boxes. So 666 boxes. Sorry about that. And remember, it's a little bit more, but it's only part of a box. You can't have part of a box. So you would go round down. If it's a real thing, you have to round down. You can't have part of something. All right, sorry about that. That was a little confusing. All right, let's take a look at the last one about cost. Let's read this together. The cost of constructing a wooden box with the square base varies jointly. Okay, so the cost, and it has a square base, that might help us in a minute, varies jointly as, so K, so cost equals K, as the height of the box and the square of the width of the box. So the width of the box squared. And that makes sense because if it's a square base, then the area of the base would be the width squared. All right, so this is our formula. We're going to solve for K here in a minute. The box height is 16, so we're just going to plug in. And the width of the base is 6. So the width is 6, so it's going to be 6 squared. And we're going to have the K we're going to solve for, and that cost is $28.80. So then you would take your calculator and you would solve. Now be really careful. This is 6 squared, so 6 times 6 is 36. So we really have K times 16 times 36, and that was equal to $28.80. And in your calculator, if you're using a blue one, you could go 28.8, and you could divide by 16, hit enter, and then you could divide again by 36. And when you do, you're going to get your constant is 0.05. All right, 0.05. So our model is C equals 0.05 HW squared, width squared. Now let's read the rest of our problem. It says, how much would a box of a height of 14 and a width of 8, square the 8, cost? All right, so we're going to find the cost based on that. We should be able to put that in our calculator. So we would have 8 times 8 was 64. So we have 64 times 14 times 0.05. And when we do, our cost is approximately $44.80. $44.80. All right, I think that's it, Bearcats. So notice on all of these your variation problems, you need to set up your problems, and then you need to solve for K, and then you need to set the model up. So we solved for K here. We had the problem. We solved for K. We wrote the model, then use the model to find your answer. So there's multi-steps there. But if you practice this, you'll understand the process, and I think you'll do great. Good luck to you all tomorrow, and go Bearcats!